All right, so again, our objectives for this morning. So the students will be able to find the determinant of a given square matrix, identify the minors and cofactors of a given matrix, and find the inverse of a given matrix if it exists using adjugate method. So last time we already uh, tackled how are we going to find the inverse of a given matrix, but using Gauss-Jordan elimination. But at this time, under determinants, we're going to use adjugate method, or we also called it adjoint method. So determinants are linked with square matrices. So these are only applicable for square matrix. You compute determinants of matrices using the elements in the matrices. Determinants are used in many applications that you find in this part module. So you see how to compute area and volume using determinants. The value of determinants are computed using one of several methods and can be evaluated using a graphing calculator or computer program. The beauty of being able to use a calculator or computer to compute determinants is especially evident as the determinants get larger, more than 3 rows and columns. So we can also get determinant of 4 by 4, 5 by 5, up to n by n matrices. Okay, it's just that we are just focusing until 3 by 3, or maybe we will try 4 by 4. And then the process of cofactor expansion extends to all sizes of square matrices and lends itself very nice to a tidy computer program. So one of the applications of determinants is in computer programming. Cofactor expansion, we already uh, discussed this. Kasi one of the methods na ginawa ng classmates nyo ay using cofactor expansion, wherein you're going to copy the first 2 columns and then multiply it diagonally, right? Minus the product also ng pataas naman. So that is cofactor expansion. So we have 2 ways to determine the determinant. One of them is cofactor expansion. Or if you want, you're going to choose you choose any row or column if you want, just to find the determinant. So the determinant of a matrix is a number that is associated with the matrix. For a matrix A, denote this number. So this is how we denote determinant. Okay, there is an absolute value symbol. So it means determinant of A, or by writing determinant of A. So it's up to you kung anong gusto nyong gamitin dyan, just to denote determinant of a given matrix. The determinant of a second order matrix. The determinant of a second order square matrix or 2 by 2 matrix, given this, is given by the number. To find the determinant of a 2 by 2 matrix, we're going to multiply it diagonally. So A multiplied by B, so that's AB, minus, multiply it again diagonally, pataas, C times B, or that is equal to BC. So to find the determinant of this matrix A, that is AD minus BC. Okay, so we will have the determinant of A is equal to AD minus BC. So let's have an example. Find the determinant of this matrix, matrix A. So we have this. So we will just multiply 2 multiplied by 4 minus 1 multiplied by 8. So we will have 2 times 4, it's 8, minus 8. So the determinant is 0. Okay, so it's like a review kasi na-discuss na naman natin yan. And then find the determinant. Another example, find the determinant of this matrix, matrix A. The determinant of matrix A is, so we'll just multiply diagonally, 7 multiplied by 4 minus 1 times 3. So 7 multiplied by 4, it's 28 minus 1 times 3, it's 3. 28 minus 3. So the determinant of A is 25. Okay. Next. Do you have questions so far? We can also calculate the matrix, the determinant of a given complex matrices. Okay. Example 3. This is a complex matrices because some of the elements are complex. Okay. So find the determinant of matrix B given this. So it's just the same. So we just need to review that I squared that is equal to -1. So in the history, the mathematician encounter an equation x squared plus 1 equals 0. Okay. And they want to determine what are the values of x. What are the possible values of x? So when we simplify this, x squared equals -1. And we know that we cannot find any value that when you squared it, the answer is -1. So they replace x by I. So I squared is equal to -1. Okay. That is, okay, power of I. I squared is equal to -1. And you continue the process kung meron mang I cube, I to the fourth. So if you are asked to find I cube, so that I cube that is also equal to I squared multiplied by I, right? Since I squared that is equal to -1 multiplied by I, so I cube that is equal to -1 times I, that's -I. Okay? And I to the fourth, that is also equal to the square root of I squared, right? So the square root of -1, that is equal to 1. Therefore, I to the fourth, that is equal to 1. But so far, you will just encounter I squared. Okay, this is just a recall. And so when we find the determinant of matrix B, it's just the same. We will just multiply it diagonally minus the product also of another diagonal. So when we get the determinant of B, -2i, multiply it by 6 plus 2i. The operations on complex numbers is just the same on how we multiply polynomials. Okay, or how are we going to multiply integers? Same process. Okay, so this is like you're going to multiply monomial by binomial. So you need to multiply -2i in each term. Okay, so -2i multiplied by 6 plus 2i minus, ito naman, 4 multiplied by 1. So -2i multiplied by 6, it's -12i. -2i times 2i, so -2i multiplied by 2i. So -2 multiplied by 2, it's -4. I multiplied by I, that is I squared. And I squared, that is equal to -1. And simplify, therefore, negative 2i multiplied by 2i, that is equal to 4. Okay? So it means that you always come up with a real number. So here, the answer is 4 minus 4. Then combining similar terms, so this will be canceled. So the final answer is negative 12i. That is determinant of matrix B. Are we clear?
Yes, ma'am.
Yes, ma'am.
All right. So let's proceed. So that is for second order matrix or for 2 by 2 matrix. So let's proceed to third order matrix. Let a 3 by 3 matrix A given by, so this is 3 by 3 matrix. The determinant of A is given by, so when we get the determinant of a third order or a 3 by 3 matrix class, you can choose, this is one of the methods that you can use. Okay? You can choose any position. If you want row 1, row 2, row 3, column 1, column 2, column 3. So you will just need to consider the sign, their position. So positive, negative, alternate, positive, negative, positive. So if you're going to choose row 1, okay, you're going to have a sign positive, determinant of the first one, you're going to multiply it by positive. Then the second determinant is 2, ay negative, and then the third is positive. When you choose row 2, it's negative, positive, negative. Row 3, positive, negative, positive. Or for column 1, positive, negative, positive. Negative, positive, negative. For column 2, for third column, positive, negative, positive. Kahit anong piliin, same lang lagi ng determinant. Okay? By the way, class, nag-stop share ako every time na nag-annotate ako kasi hindi ako makaka-proceed. Makaka-proceed naman ako sa next page kaso mag-move din to. Kaya ako nag-stop share. Kasi baka sabihin nyo, ba't lagi ako nag-stop share? SKL. Anyway, so let's find the determinant of matrix C. Okay? 4, 0, 2, 1, negative 2, 5, 1, 0, 1. So again, I told you, any position. Halimbawa, piliin natin, ang pinili ko dito ay for row 1. The determinant is negative 4. So let's choose another position. So when we choose, halimbawa, pinili ko ang column 2 kasi may dalawa ng 0. When you multiply it, so ang 3 by 3, ang natitira 2 by 2. Ibig sabihin, pag ang given ay 4 by 4, may matitirang 3 by 3. So medyo yon mahirap kasi kukunin mo yung determinant ng 3 by 3, multiply doon sa value kung ano man ang pinili niyong position sa 4 by 4. So dito muna tayo mag-focus sa 3 by 3. So piliin ko ang column 2. Sa column 2, ang sign niyan ay negative, positive, negative. Anyway, this is just 0. So any number na may matira, di ba? Halimbawa, kunin natin ang determinant ng column C. Piliin ko to 0, tapos may matitirang 2 by 2. So i-delete natin yung nasa baba ni 0 at nasa left at right. So we will have 1, 5, 1, 1. 1, 5, 1, 1. So, ano ba yung ibig sabihin ko kanina? Pag sinimplify nyo to, kinuha nyo yung determinant nito, whatever the value, you're going to multiply it by 0. So, ibig sabihin, 0 pa din to. Kasi any number multiplied by 0 still 0. So, it's easy to find the determinant kung merong entry or merong element or elements na 0. Okay? So, this is 0. So, next is positive. Positive multiplied by negative, okay, still negative. Negative 2. Tapos, we're going to delete yung mga nasa left at right, taas at baba. So, meron tayong 4, 2, 1, 1. 4, 2, 1, 1. Then, negative. 0 pa din naman to. So, kahit hindi nyo na isulat. Or if you want, you write 0. And then, yung matitira dyan, 4, 2, 1, 5. 4, 2, 1, 5. And then, you get the determinant. You can simplify. This is 0. So, dito na tayo mag-focus. Negative 2. 4 times 1, 4. Minus 1 times 2, it's 2. Then simplify. Negative 2 multiplied by 4 minus 2, it's 2. So, negative 2 multiplied by 2, the determinant of C is negative 4. It's just the same. Negative 4. So again, dito sa module, ang pinili ko ay row 1. The sign for row 1 is positive, negative, positive. Okay? Positive, 0 naman yung pangalawa. So that's negative. So hindi ko na nilagay. And then positive again for this. Row 1, column 3. Kaya siya positive 2. Okay? Tapos yung matitirang 2 by 2. Okay, so that's one of the methods that we can use. And yung kanina nabanggit, yung cofactor expansion, cofactor expansion, yung ginawa ni Ira last time, nag-add ng, kinopya yung dalawang first two columns. Okay, dito. Kokopyahin mo yung first two columns and then you multiply it diagonally. 0, negative 2, 0. Okay, so the determinant is, this is 4 times negative 2 times 1, it's negative 8. This is 0. This is also 0. Minus lagi ng pataas. So this is 1 times negative 2 times 2, it's negative 4 times negative, kasi minus minus times negative 4. So it becomes positive 4. And this is also 0, and this is also 0. Okay, so when we simplify it, negative 8 plus 4, it's still negative 4. So this is cofactor expansion. Kasi you expand it, you just copy the first two column and you do the same process, multiply it diagonally. Find the product of each diagonal minus lagi ng pataas. Okay, so that's another way of finding the determinant if you don't want to use this method. Clear? Are we clear? Okay. Next. Theorems about determinants. The determinant of a matrix with two rows or two columns that are identical is 0. When you get the determinant wherein same ang row nila o kaya either row or column, both of them are the same. Halimbawa ito, same ang column 1 and column 2. When you get the determinant of that, it's always 0. So when we show if this is true, this theorem, so find the determinant of matrix A times B, it's AB, minus A times B, it's AB. AB minus AB, it's 0. Okay, so dito, one of the theorems, it says that if you get the determinant of a matrix with two rows or two columns that are identical, okay, so dapat dalawa class. It's either row or column. Basta dapat both of them are the same. Their determinant is always 0. Okay, next. It's one of the theorem. Next is swapping rows or columns in a matrix. When we say swap, pagpapalitin nyo. If we swap two rows or two columns of a matrix, the determinant changes sign. Nagpapalit daw. So, ibig sabihin, given two matrices, pag kinuha mo, kasi ito negative 1, 2, row 1 sa matrix A. Sa matrix B, second row siya. Yung second row dito, first column dito, ibig sabihin, pinagpalit mo lang sila. This is matrix A. Okay, so pagdating sa matrix B, swap nitong dalawa. Your row 1 become your row 2, your row 2 becomes row 1. So when you get the determinants of two matrices, magbabago lang. So magiging negative ng determinant ng isa. So that is the other theorem. Determinant of matrix B that is equal to negative determinant of matrix A. So halimbawa, so let's show that this is true. Okay? Pag sinabing show that, class, hindi nyo lang kailangan i-graph. Kailangan yung patunayan, ipakita na totoo. Ganun kasi ang nangyari sa exam nung iba sa analytic geom. So, ginrap lang nila. Hindi natin mapapatunayan na totoo nga siya, that is true. You just need to, ang ginawa nyo lang, ginrap nyo lang. So, paano nyo nasabing totoo nga yung theorem na yon? You need to prove it. Ipakita nyo, okay, na ito ay totoo. So, how are we going to show that matrix A and B, okay, this will satisfy their theorem? Of course, you need to get the determinant of A and the determinant of B and see if this is true. Okay, you use this theorem. When we get the determinant of A, negative 1 multiplied by 8, that's negative 8, minus 4 times 2, it's 8. So negative 8 minus 8, that's negative 16. Next, let's find the determinant of B. 4 times 2, it's 8. Minus negative 1 times 8, so it's negative 8 times negative, so it becomes positive. So this is 8. 8 plus 8, that is equal to 16. And when we show that if this is true, determinant of B, that is equal to 16. And negative, determinant of A, that is negative 16. Okay? They are equal. It's just that they are opposite to each other. So it means this is true. Okay? So yun siya. And we see that determinant of B is equal to the negative of the determinant of A that is already satisfied. Okay, so sa math, hindi lang natin laging sinasabi lang in words. We do it in action. So next, Kramer's rule. Nagkaroon na rin ako ng pahapyaw nito. Kramer's rule is also discussed in sa BSEM 22 algebra, college and advanced algebra, because one of the topics there is about system of linear equations. We can use Kramer's rule. At napahapyawan ko din to kasi ginamit natin to, yung kukunin natin ang determinant, dx, dy, dc for 3 by 3 or for 2 by 2, or if we have two unknowns, the x and y, we need to identify the dx and dy. Ang tawag dun, class, we apply determinants pa din. But the process or the method that we use is Kramer's rule. Kramer's rule is a simple algorithm that allows determinants to be used to solve systems of linear equations. A rectangular array of numbers of m rows, and this is n columns. N columns is a square matrix of n order. The number which is associated with the square matrix is called determinant of the matrix. The array of numbers in rectangular form is composed of the elements of the matrix. The vertical arrangement of numbers shown the columns. So, ito ay na-discuss na din. It's just that they define matrix. It's a rectangular array, okay, that consists of rows and columns. So we have A1, A2, B1, B1, and B2. That consists of row, okay, and column, okay. And then the number of which is associated with the square matrix is called the determinant of the matrix. So again, determinant is only for square matrix. Ang tawag daw doon na kinukuha natin when we find or we are performing operation for square matrix is called determinant. The array of numbers in rectangular form is composed of the elements of the matrix. So these are the elements of the given matrix, A sub 1, A sub 2, B sub 1, B sub 2. We also call them entries or elements. The vertical arrangement, we know that these are columns. Okay? Pagpatayo, column. Pag horizontal, that is row. And then the determinant of a matrix is usually written by enclosing the elements of the matrix by vertical bars. So mostly we use bracket or pwede din naman class ang parenthesis. But mostly we use bracket o kaya minsan yung parang ganito, yung pang absolute value sign. It's just that usually we use this bracket. As matrix is square matrix if the number of columns is equal to the number of rows. So you already know that row is equal to the number of rows is equal to the number of columns. We call that square matrix. So example of determinants is to order R. So this is a 2 by 2 matrix is a determinant of the square order, second order matrix or a 2 by 2 determinant. And this is a 3 by 3 order. Okay, we can also get the determinant of a third order matrix. In example 1 above, the elements 3 and 2 represent the principal diagonal, right? So this is the principal, 3 and 2. And the elements 4 and 5 represents the secondary diagonal, 4 and 5. The value of determinant may be obtained by subtracting the product of the elements of the secondary diagonal from the product of the elements of the primary diagonal. So that's how we get the determinant of a 2 by 2. Okay? We subtract the product, okay, of the elements of the secondary by the product of the principal diagonal. And to solve a system of linear equations by using determinant, observe the steps and procedures enumerated below. Write each of the linear equation in the form ax plus by equals c. So make sure that the given system is in standard form. This is the standard form for linear equation. And we are talking about system. So we have two or more linear equations. And then form the determinant of the matrix using the values of A, B, and C of the linear equations as elements. So we just need the numerical coefficient of each term. And then solve each of the values of the unknowns x and y based on the following definition. So if we are asked to find the x, we just need to get the determinant of this, the dx, the dy. And then to find the value of x, that is dx over d. And for y, so this is the determinant of x divided by the determinant of the given system. For y, that's dy over d. Make sure that the value of the determinant is not equal to 0. Kasi mag-undefined. Okay? So, ito yung long process niya. How are we going to find the tx? So, the d, alam natin, itong nasa loob, the numerical coefficient of x and y. And for dx, we're going to copy y and copy y and change your x as the constant. So, ibig sabihin, itong constant magiging value sa x and y retained. For y, kopyahin yung numerical coefficient ng x and then copy the x and then yung sa y, kokopyahin nyo yung numerical coefficient ng constant or copy the constant that will be for the y. Okay, so let's have example para mas madaling intindihin. So, this is not only applicable class for 2 by 2 or if we have two unknowns. This is also applicable for 3 by 3 or if we have three unknowns, x, y, and z. So for the third order matrix, ganoon naman, sa x, babaguhin si x ng constant, y and z retain. For y, di ko na lahat dito sinulat eh. Same, ano lang nang naman siya kung paano. Parang this is just a guide. For dy, papalitan ng y ng constant, x and z retain. For z, x and y just retain, and then z, copy your constants. So to solve for a third order matrix, form the determinant of the numerator using as element the numerical coefficient. So better if we give example para mas wait. Magbo-board ako class. Kailangan ko lang yung given. Okay, so let's have example for 2 by 2. Find the solution to the system 3x minus y equals 4 and 2x plus y equals negative 2. So sabi kanina class, we need to check if the given system is in standard form. So obviously the given is already in standard form and we're going to write this in matrix form. So we're going to get their numerical coefficient. So we will have 3, 2. So be careful when you write this or you get the numerical coefficient. Kasi pag may isang mali, mamamali na. So we have 3, 2, negative 1, 1, 4, negative 2. And since this is only two unknowns, okay, so we can check if this is one solution, no solution, or infinitely many. So we have 3 halves. Is it equal to, so negative 1 divided by 1, it's negative 1. Obviously, they are not equal. Therefore, this is one solution. Okay? And then we get the determinant. Determinant plus itong nasa loob. So we'll just copy 3, 2, negative 1, 1. And we multiply the principal diagonal minus the secondary. So 3 multiplied by 1 minus 2 times negative 1. So 3 multiplied by 1, that is 3. Negative 2 times negative 1, it's 2. So 3 plus 2, that is equal to 5. Since the determinant is non-zero, it means we can find the solution. But before that, let's find tx. So again, dx, you're going to replace your x as your constant. So 4, -2, and y retain, -1, 1. Again, to find the determinant of dx, just copy your y, and for your x, copy your constants. So then let's find the determinant. 4 multiplied by 1 minus -2 multiplied by -1. 4 multiplied by 1, that is equal to 4. Minus -2 multiplied by -1, that is positive 2. So 4 minus 2, that is equal to 2. Okay? So therefore, to find the value of x, that is dx, that the determinant of dx divided by your determinant. Dx, that is equal to 2 over 5. So x is equal to 2/5. Next, dy, the determinant of dy. So for dy, you copy your x, the coefficient of x, and y, you replace, okay, by the value of your constants, which is 4 and -2. So 3 multiplied by -2 minus 2 multiplied by 4. Then simplify, 3 multiplied by -2, -6. -2 times 4, it's -8. So we'll have -6 minus 8, it's -14. So to find the value of y, it's the determinant of dy over the determinant of t. So dy is -14 over your d is 5. So simplify if you can simplify it. So therefore, the solution set is 2/5 and -14/5. You can double check your answer. You substitute here in the given system. Okay, so kayo na mag-check niyan. Is it correct? 3 multiplied by 2/5 plus 14/5, is it equal to 4? Is it equal to 4?
Yes po, ma'am.
Yes,
How
ma'am.
about 2 multiplied by 2/5? So that's 4/5. 4/5 plus -14/5. Is it equal to -2?
Yes po.
All right, so that is the answer. Next. How about for 3 unknowns? Find the point of intersection of the 3 planes defined by x plus 2y minus z equals 4. 2x minus y plus 3z equals 3. And 4x plus 3y minus 2z equals 5. So let's double check. The given system is x plus 2y minus z equals 4, 2x minus y plus 3z equals 3, and 4x plus 3y minus 2z equals 5. So let's write this in matrix form. Since the given system is already in standard form, we can now transform this into matrix. So we will have 1, 2, 4, 2, -1, 3, -1, 3, -2. And then for constants, we have 4, 3, and 5. Again, double check this. 1, 2, 4, 2, -1, 3, -1, 3, -2, 4, 3, 5. All right, so let's find now the determinant. Okay, so for determinant, we will have 1, 2, 4. Yung nasa loob class, 2, -1, 3, -1, 3, -2. Okay. So, for example, hindi ako expansion, cofactor expansion. I choose row 1. For row 1, the sign is positive, negative, positive. Again, hindi ko nire-require na row 1 ang piliin. Gusto ko lang row 1. Kung anong gusto nyo, yun ang gawin nyo. So, when we choose row 1, so we will have positive 1. So, 1. And then may matitirang delete yung nasa right, nasa baba niya. So, we will have -1, 3, 3, -2. Negative times 2. So, -2. Wala kasing zero class eh. So, row 1 na lang. Again, kahit ano naman ang piliin. So, let's delete yung left at right ni 2, nasa baba niya. So, we'll have 2, 3, 4, -2. Just be careful dun sa mga natitira class. Kasi minsan dun nagkakamali. Naduduling yung iba na mamali ng kopya. So, again, we will have 2, 3, 4, -2. Next, positive times negative, still negative. So, -1. Delete yung nasa baba at nasa left. 2, -1, 4, 3. Okay? And then, find the determinant now. 1. So, this is -1 times -2. It's 2 minus 9. Minus 2. 2 times -2, it's -4 minus 12. Minus 1. 2 times 3, it's 6. This is -4 times negative, positive. To simplify, 2 minus 9, it's -7 times 1, -7. This is -16 times -2, positive 32. 6 plus 4, that's 10 times -1, -10. Then simplify. So your D is sa baba. -7 plus 32 minus 10.
15 po.
It's 15. 5. Okay. Next, dx. So for dx, we replace the numerical coefficients of x by your constant. So we'll have 4, 3, 5. And y and z retain 2, -1, 3. -1, 3, -2. Okay. So piliin ko naman ang column 3. For column 3, positive, negative, positive, negative, positive. Positive, negative, positive. So we will have 4. May matitirang -1, 3, 3, -2. Then, negative times 3. Ay, sorry, not 4. Bakit 4? I just wrote column 3 pala, class. So we'll have negative 1. Ginawa ko row 1. Okay, so negative 1, delete, nasa baba, nasa left. So we'll have 3, negative 1, 5, 3. Next, negative times 3, negative 3. So delete this. So 4, 2, 5, 3. Next, positive times negative 2, negative 2. 4, 2, 3, negative 1. Then simplify. So negative 1 multiplied by 9 plus 5. It's 14. Next, minus 3. Hindi ko na class sinulat to kasi kulang sa space. 4 times 3, it's 12 minus 10. It's 2. Minus 2. Negative 4 minus 6. It's negative 10. So when we simplify, negative 14 minus 6, negative 20, plus 20, it's 0. Again, negative 14 minus 6, negative 20. Negative 14 minus 6 plus 20. So this is negative 20 plus 20. So your dx is equal to 0. Okay? So when we get x, that's dx over d. Okay lang naman, class, na mag-0 ang dx. Wag lang ang determinant. Kaya nag-proceed tayo. Ibig sabihin, class, pag ang determinant nyo 0, hindi nyo na kailangan kunin ng dx, dy, or dz kung 3 unknown siya. Dito naman kasi non-zero siya. Okay? Okay lang na negative, positive, wag lang 0. So dx is 0 over 15, still 0. The value of x is 0. Next, dy. So for dy, class, we're going to copy x and z and y retain. So we have 1, 2, 4 for x. Si y ay papalitan natin ng constant, 4, 3, 5. And z, just retain, negative 1, 3, negative 2. Again, so let's double check. For dy, we just copy x and z, 1, 2, 4, negative 1, 3, negative 2. And for y, copy your constants, 4, 3, and 5. Now let's find the determinant of y. So, piliin natin ang column 1. Positive, negative, positive. Positive, negative, positive. Okay, so we will have positive times 1, still positive. At may matitirang delete. Nasa right, nasa baba. 3, 3, 5, negative 2. 3, 3, 5, negative 2. Negative times, again, we choose column 1. Negative times 2 is negative 2. Delete, nasa right, baba, taas. 4, negative 1, 5, negative 2. Then, positive times 4, it's positive 4. Delete again, nasa right, baba. 4, negative 1, 3, 3.
Ma'am, ask ko
Then,
lang po. Di pa po pwede po kahit row po yung gamitin?
what?
Kahit row yung gamitin po.
Yes po. Kahit anong method ang gamitin or kahit anong posisyon, ako na lang nagde-decide class kasi sayang sa oras eh. So, pwedeng row 1, row 2, row 3, column 1, column 2, column 3. Just remember yung sign nila kasi yung position nila, it matters. Kung positive yon or magiging negative. Okay? Kasi magbabago ang sagot nung nasa loob pag minultiply mo dito. Okay, so let's continue. 3 times negative 2, it's negative 6 minus 15. Negative 6 minus 15, negative 21. Minus 2, this is negative 8 plus 5. It's negative 3. Again, pwedeng isulat nyo step by step. 4 times 3, it's 12. This becomes positive. 12 plus 3, it's 15. Simplify, 1 times negative 21, negative 21. This is positive 6. This is 60. So, negative 21 plus 6 plus 60. What is
45.
dy?
45 po.
All right, so it's 45. So, to find the value of y, dy over t. So, ang dy natin, 45. Ang d natin, class, ay 15. So, y is 45 divided by 15, it's 3. Okay, last na. D, the determinant of DC. So, for DC class, we're going to copy, just copy x and y. 1, 2, 4, 2, negative 1, 3. And z, change it, copy your constants. 4, 3, 5. Again, double check TC. X and Y retain. So 1, 2, 4, 2, negative 1, 3. Change your Y. Okay, copy your constant. 4, 3, 5. Okay, so pili tayo ulit. Halimbawa, row 2. Row 2. So
Negative,
positive,
positive.
negative. So we have negative, positive, negative. Okay, so we'll have negative times 2, it's negative 2. Then delete, so 1, 4, 4, 5. 1, 4, 4, 5. Positive times negative 1, still negative 1. Then delete. Wait.
Ma'am, ano po? 2, 4 po.
Yeah, I saw it. So we'll have 2, 4, 3, 5. Okay. So again, row 2, negative times 2, it's negative 2. Delete, so we'll have 2, 4, 3, 5. Next, positive times negative 1, it's negative 1. So we'll have 1, 4, 4, 5. Next, negative times 3, negative 3. Delete, 1, 2, 4, 3. 1, 2, 4, 3. Double check again. 1, 2, 4, 3. And find the determinant now. Negative 2. So this is 10 minus 12. It's negative 2. 5 minus 16. Negative 11. Negative 3. 3 minus 8. Negative 5. Simplify. This is 4. This is 11. This is 15.
30 po.
So, DZ is equal to 30. So Z is equal to dz, the determinant of dz over the determinant of d. dz is 30 and d is 15. So Z is 2.
2.
So we have 0, 3, and 2. Okay, you check your answer in the given system. So we'll have 6 minus 2. Is it equal to 4? Yes. Negative 3 plus 6. Is it equal to 3? Yes. 9 minus 4. Is it equal to 5? Yes. So our answer is correct. Any question, class?
Ano po?
Okay, so that's how we do Kramer's rule. Okay, so let's continue. Properties of determinants. So we now list some important properties of determinants. Number 1, the determinant of a product of matrices is the product of their determinants. So it simply says that the determinant of AB, which is this is a product of A and B, that is equal to the product of their determinant. Determinant of A multiply by determinant of B. So you can give example. Siguro, itry nyo siya. 2 by 2 lang muna para mapatunayan na totoo to. But this is already a property. So, ibig sabihin, napatunayan na yung totoo. So, we'll just show some example later. Or kayo na lang mag-try kasi mauubos yung oras natin. Next, if the determinant of a matrix is non-zero, then the matrix has an inverse. So, ibig sabihin, class, pag nakuha nyo yung D, katulad kanina, yung sa system natin, ang value ng determinant nila is non-zero. When we say non-zero, any number except 0, positive man yan or negative, that matrix has an inverse. Okay? So that's another property. Next, if a matrix has a row or column of zeros, then the determinant of A is 0. Okay? So, pag merong row na puro 0, halimbawa row 1, yung elements ni row 1 puro 0, ang determinant nun 0 na. Kasi nga, pag minultiply mo, halimbawa, 0, 0, AB, halimbawa. When we get the determinant of this, 0 times B, 0, minus 0, still 0. Or kahit column, 0, 0, AB. Still, ang determinant pa rin yan, 0 class. 0 times B, still 0, minus 0, still 0. That's third property. If a matrix has a row or column of zeros, then the determinant of A is 0. Okay? Next, number 4. The determinant of a triangular matrix is the product of the diagonal elements. Pag sinabi nating triangular matrix, class, itong part na to. Kasi para kang bubuo ng triangle. Okay? Ang determinant daw niyan ay product ng diagonal. So pag kinuha mo yung product ng diagonal, equal yon sa determinant ng given triangular matrix. So hindi pa natin na-discuss tong triangular matrix. Sa mga susunod na lang yan. Okay, next. If the row or a column of a matrix B is multiplied by a scalar, just the alpha, to give a new matrix A, then the determinant of A is equal to the scalar of determinant of B. So pwede nyong ipakita yan. You can show that this property is true. You give matrix A, matrix B, and you give value, any value naman sa scalar class. Then just follow this. Ibig sabihin nito, determinant of A, kunin nyo yung determinant ni A. Pag nakuha nyo yung determinant ni A, kunin nyo pa yung determinant nun. Kasi dalawang beses eh. Is it equal to this? Get the determinant of B. Your determinant of B, multiply it by a scalar. Diba ang determinant of A, it's a real number. Multiply it by the determinant of that. It's also a real number. Ganon din dito. Kasi determinant of B, ang makukuha natin, any real number, multiply by your scalar. So, ibig sabihin, ang makukuha mo ay real number din. Okay? So, meron naman dito, example 9, show that the determinant of AB is equal to the determinant of A multiplied by determinant of B. This is property 1, that the determinant of a product matrices is equal to the product of their determinants. So let's try this example. Right. So we're going to show that the determinant of AB is equal to the product of their determinant. Given that matrix A is 2, 4, 3, 5. And matrix B is -2, 4, 1, 2. Okay, so kunin muna natin. Bago natin ito makuha, kailangan natin kunin ang product muna. Product ni AB. So 2 times -2, -4. 3 times 1, 3. So again, how are we going to multiply matrices? Row by column, right? Then, and we can multiply them since they are both square matrices. So same ang row ng matrix A sa column ng matrix B. They are both square matrices. So obviously we can multiply them. So let's find the product. 2 times -2, it's -4. 3 times 1, it's 3. Next, row 1, second column. 2 times 4, it's 8. 3 times 2, it's 6. Next, row 2, column 1. -4 times -2, -8. 5 times 1, 5. 4 times 4. Next, row 2, column 2. 4 times 4, it's 16. 5 times 2, it's 10. Then simplify. So we'll have -4 plus 3, it's -1. 8 plus 6, it's 14. -8 plus 5, it's -3. 16 plus 10, it's 16. Okay, again, double check. -2 plus
26
-4
po.
plus, sorry, it's 26. Kaya ako class nagdo-double check kasi minsan na overly ko. 2 times -2, -4, 3 times 1, 3, 8, 6, -8, 5, 16, plus 10. Simplify, -1, 14, -3, 26. And then, you get the determinant of this. For this, on the left side, determinant of AB. So when we get the determinant of this, -1 times 26, it's -26 minus, this is -42, so plus 42. So -26 plus 42, it's 16. Is it
Yes po.
16?
16.
Okay, that's determinant of AB. Next, determinant of A. Determinant of A, 2 times 5, it's 10, minus 4 times 3, it's 12. 10 minus 12, it's negative 2. Determinant of B is negative 2 times 2, it's negative 4, minus 1 times 4, it's 4. Negative 4 minus 4, it's negative 8. So when we check, determinant of AB is equal to determinant of A, determinant of B. Determinant of AB, that's 16. Is it equal to determinant of A, that's negative 2. Determinant of B, that's negative 8. Negative 2 times negative 8, it's equal to
Positive
16. Okay? So that is true. Clear?
Yes, ma'am. Here po.
Yes po.
Yes po.
Okay, next. Find the determinant of B in 2 ways. So for this, you can use expansion or so let's use expansion kasi kanina ang ginamit natin, pipilit tayo. Though pwede naman class kasi may dalawang 0. Sige, let's do number 10. The given matrix B is 1, negative 2, 4, 0, 6, negative 2, 0, 0, 1. So let's find the determinant of B. I'll choose row 3. Kasi may dalawang 0 na siya. Positive, negative, positive. Row 3, positive, negative, positive. So this is positive. So we'll have 1, then may matitirang delete 1, negative 2, 0, 6. Double check. 1, negative 2, 0, 6. So we'll have 1 multiplied by 1 times 6. It's 6. And this is 0. Minus 0. So 6 minus 0, it's 6 times 1. 6. So the determinant of B is 6. How about using expansion? So we'll have 1, 0, 0, negative 2, 6, 0, 4, negative 2, 1. So we're going to add, we're going to copy the first 2 columns. 1, 0, 0, negative 2, 6, 0. Then multiply the principal. This is 6. This is 0. This is also 0. This is 0. This is 0. This is also 0. So this is the determinant, 6. It's just the same. Okay? Can you follow?
Yes, ma'am. Yes po.
Okay, next. Prove that if the first row of a third order square matrix is all zeros, the determinant is 0. So ito yung kanina sinasabi ko. If any of the row or column are zeros, the determinant is 0. So pag tayo ay piliin natin ang row 1 kasi puro 0 yan eh. 0, multiply kung ano man ang product dito, 0 pa din. 0, positive, negative. minus 0, kung ano man ang makuha ang sagot dito, multiply by 0, still 0. Okay? Ganon din dito, class. So, ibig sabihin lang, yun nga yung sinasabi kanina, if any of the row or column are zeros, the determinant of that matrix is 0. Okay? So, pwede nyo itong itry. Hindi na natin ipapakita. Next, number 12. Prove that if the first column of a matrix B is multiplied by a scalar to give a new matrix, then determinant of A is equal to the alpha determinant of P for a third order matrix. So, given this matrix, class, you show this. How are we going to show it? Since ang mga elements ay hindi naman real number or complex, ibig sabihin, letter lang din. Dapat, pag kinuha nyo ang determinant of A, equal dito. Okay, hindi rin naman binigay yung value ng scalar. So, kayo nang bahala. Kung ang value ng scalar is a real number, still, dahil wala naman, ang loob naman ay hindi real number, ang sagot ay hindi pa rin real number. Okay? So, itry nyo to. Determinant of A is equal to the scalar of determinant of P. That is true. Okay? Kayo na mag-try niyan kasi kulang tayo sa oras.
Ma, marami tayong oras. Alauna lang tayo. 2 hours.
Ito-try nyo lang naman yan, class. Halimbawa, kunin nyo tong determinant. This is A dapat kasi A yun. Wait. Prove that if the first column of matrix B is multi, then determinant of A is equal to alpha of determinant of B. So ito ang binigay na. Pwede namang wala to. Kayo na ang magbigay ng matrix nyo. Basta daw, yung first column ng matrix B, ano ba yung first column? Ito. I-multiply nyo sa value ng scalar. Magkakaroon ka ng yun yung matrix A mo. So, halimbawa, sige na nga. Alpha is, mahaba kasi class yung inverse. Ang alpha mo ay 3. So, ang matrix A mo, kayo na lang mag-continue. Multiply mo 3 times A sub 1, 3A sub 1, 3B sub 1, 3C sub 1. Tapos, ganun pa din sa ibang elements. Okay? Tapos, follow nyo to. Kunin nyo ang determinant ni A. Tapos, kunin nyo ulit yung determinant nun. Tulad lang ng ginawa natin kanina, class. Tapos, kunin ang determinant ni B, i-multiply dito. Dapat equal yan sila. Ganun lang. Okay? So, itry nyo. Kayo naman ang mag-try, class. That is, tawag doon, sa method na yun, discovery method. Anyway, meron naman kayong susundin, hindi naman siya talagang kayo lang ang magdi-discover eh. Okay, next, finding the inverse of a matrix. Medyo mahaba kasi to. We need to get the minors, cofactors, the determinant of the given matrix, and then the adjoint or adjugate before we get the inverse. Last time, in finding the inverse of a matrix, we are using Gauss-Jordan elimination. But at this time, since our topic is about determinants, iba ang method natin. So we're going to use adjugate method. And it says there kanina sa properties, no, not in the property. It says there in the theorem, not all matrices have inverse. Okay? If the determinant of the given matrix is non-zero, therefore, the inverse exists. Okay? So, hindi lahat ng matrix ay may inverse. dapat ang value ng determinant is non-zero. Okay? So if the determinant of a matrix is non-zero, the inverse exists. So we calculate the inverse of A by using the determinant and the adjugate, a matrix whose ith row, jth column entry is found by calculating the cofactor of the entry, ith row, and jth column of matrix A. Okay, so again, pag ang determinant na nakuha nyo ay 0, hindi nyo na kailangan kunin ng inverse kasi wala siyang inverse. Don't forget. Okay? So, before we discuss adjugate, you need to have first the minor, the cofactor, and adjoint or adjugate. Because to find the inverse of a matrix, that is 1 over the determinant of the given matrix multiplied by the adjoint of the given matrix. So what do we mean by minor? Let matrix A sub Mn be the submatrix formed from A by eliminating the mth row and nth column of A. The minor associated with N3 Mn of A is the determinant of AMN. Matrix A sub Mn. Yung kinukuha natin class na values na nasa loob, halimbawa, find the minors. Halimbawa, minor ng A sub 1, 1. Yung natitira sa loob, yung determinant no, na 2 by 2, ang tawag doon minor. Minor of A sub 1, 1. Ibig sabihin, row 1, column 1. So, negative 2, delete yung nasa right, below. 4, 5, 1, 4. Yung value nito na makukuha dyan, ang tawag dyan ay minor. Okay? So, when we get the minor of this given matrix, ibig sabihin lahat na kunin natin. Ginawa natin to last time class kasi ang ginamit ni Ira ay hindi. Tama ba? Ira, ikaw nga ba yun?
Yes
Ay
po.
cofactor expansion. Okay, so let's find the minors, the given matrix. Okay, so matrix A, negative 2, 3, 1, 0, 4, 5, 2, 1, 4. So we denote minors, sabi A sub NN. So A, laki masyado. A11, ito na lang. A11, ibig sabihin row 1, column 1. Since this is 3 by 3, meron tayong siyam. Kasi 9 yan 9 elements. A11, A12, A13, A21, A22, A23, A31, A32, A33. That's how we denote minors. Okay, so 1, 1. Ito yan. Delete. May matitirang 4, 5, 1, 4. Okay, so pwede nyong isulat yung natira or diretso na 4, 5, 1, 4. Pero isulat natin para hindi tayo malito. So 4 times 4, 16. Minus 5, it's 11. 1, 2. Ito si 3. Delete, delete. 0, 5, 2, 4. 0, 5, 2, 4. Double check again. 0, 5, 2, 4. This is 0 minus 10. So negative 10. A13. Row 1, column 3. Delete, delete. 0, 4, 2, 1. 0, 4, 2, 1. This is 0 minus 8. So negative 8. Next, 2, 1. Row 2, ibig sabihin yan class, row 2, column 1. So ito siya, 0. Delete, delete. 3, 1, 1, 4. 3, 1, 1, 4. 3, 1, 1, 4. 3 times 4, it's 12 minus 1, 11. 2, 2. Row 2, row 1, row 2, column 2. So 4. Delete, delete. Negative 2, 1, 2, 4. Again, double check. Negative 2, 1, 2, 4. So, negative 2 times 4, negative 8 minus 2. Negative 10. 2, 3. This one. So, we will have negative 2, 3, 2, 1. Again, negative 2, 3, 2, 1. Negative 2 minus 6. Negative 8. Next, row 3, column 1. Row 3, column 1. 3, 1, 4, 5. 3, 1, 4, 5. So, 15 minus 4, 11. Next, row 2, column 2. This one. Negative 2, 1, 0, 5. Again, row 3, column 2. Negative 2, 1, 0, 5. Negative 10. Row 3, column 3. This one. Negative 2, 3, 0, 4. So we will have negative 8. Okay, so that's how we find the minors. Next is, we will continue sa cofactors. Continuation lang din ng example na yan. How about cofactor? To find the cofactor for entry Mn of a matrix A, we calculate the sign minor for entry Mn, which is given by the n power of m, the m plus n power of negative 1 multiply by, excuse me, determinant of uh, a, determinant of A sub mn. We denote the cofactor by A sub nn. You don't need to memorize this. Para mas madaling makuha ang cofactor, just remember their position and multiply it. If the sum of the position is even, you're going to multiply it by positive. If the sum of the position, kaya may mn m rows and columns. If the sum of the position is odd, you're going to multiply it by negative. So 1, A22, A23, A31, A32, A33. Kaya tayo class nag-come up sa positive, negative, positive. Kasi when you add this even number, your answer is positive. If the sum is even. 1 plus 2, it's 3, it's odd, therefore it's negative. Alternate. So we denote cofactors, lowercase naman, A11, A12, A13, A21, A22, A23, A31, A32, A33. 1 plus 1, it's 2. It's positives. Or ito, positive times 11, 11. So alternate naman yan, positive, negative, positive, negative, positive, negative, positive, negative, positive. Basta pag ang sum class ay add times negative, pag even numbers, multiply it by positive. This is add. So negative times negative 10, positive 10. Or dito kayo na lang. Okay? This is a sub 1, 1, a sub 1, 2, a sub 1, 3. A sub 2, 1, a sub 2, 2, a sub 2, 3. A sub 3, 1, a sub 3, 2, a sub 3, 3. Okay? Kayo nang bahala kung anong titingnan nyo. Ito ba or ito or yung sum nila. Ito ay even. So positive times negative, negative 8. Kung ayaw nyong alalahanin yung formula, this is add. So negative times positive, negative 11. Next, positive times negative, negative. Next, this is negative times negative 8, positive. Next, positive times positive, 11. This is negative times negative 10, positive 10. This is positive times negative 8, negative 8. You need to be careful. May isang mali dyan, mamamali ang inverse. Okay? So when we write this, ang adjoint naman class, dire-diretso na natin, is the transpose ng cofactors. So, adjugate. The adjugate of a matrix A is the matrix of the cofactors for a 3 by 3 matrix. As you've noticed, adjoint of A is the transpose of your cofactors. Diba meron tayong A sub 1, 1, A sub 1, 2, A sub 1, 3. You get the transpose of that. That is adjoint. Okay? You interchange your row by column. Okay, so when we get the adjugate of the given matrix, so kung gusto nyo, isulat nyo na muna ang cofactors. So ang cofactors natin class, so this is minors. This is the cofactors. So ang cofactors natin, 11, 10, negative 8, negative 11, negative 10, 8, 11, 10, negative 8. Double check again. 11, 10, negative 8. Row 1, row 2, negative 11, negative 10, 8. Row 3, 11, 10, negative 8. It says there that adjugate of A is the transpose of your cofactors. So we're going to interchange your row by column. So we'll have 11, 10, negative 8, negative 11, negative 10, 8, 11, 10, 8. Sorry, negative 8. Again, interchange. Your row 1 becomes column 1. 11, 11, 10, negative 8. Row 2 becomes column 2. Negative 11, negative 10, 8. Row 3 becomes column 3. 11, 10, negative 8. This is your adjugate. Adjugate of A or adjoint of A. Okay? Next. Magkakadugtong yung mga topics sa dulo. Inverse. If the determinant of A is non-zero, then we can get the inverse since it's a non-zero. The inverse of A, this is how we denote inverse, right? that is equal to 1 over the determinant of A multiplied by adjoint of A. That's why you need to be careful in finding your minors and cofactors. And then you get the transpose of that to find the adjoint. Kasi may isang element ng magkamali, mali na lahat. Okay? Naging considerate lang ako sa exam. Sige, kahit isang element, dalawang elements ang mali, tama na. Pero alam naman natin, in mathematics, it should be exact. Dahil pag may isang entry na mali, may iba na, hindi na magsasatisfy yung given system or equation, right? Pero dahil nag-effort naman, sige, may isa lang na mali. Pinagbigyan ko na isa or dalawa. Wag naman marami pa sa dalawa. So that's how we get the inverse. 1 over the determinant of A multiplied by adjoint of A. Okay? So you need to check first your determinant. Find the determinant of the given matrix. If it's non-zero, then the given has an inverse. So let's continue first dito sa ginawa natin kanina sa 3 by 3. Ano muna ang determinant nito? Okay, so let's continue. Let's find the determinant of A. Baka naman 0. So we'll have negative 2, 3, 1, 0, 4, 5. 2, 1, 4. Siguro let's choose this one. Column 1. Kasi may 0. Positive, negative, positive. Okay, so let's find the determinant of A. Positive times negative, still negative 2. 4, 5, 1, 4. 0 naman yung this one, row 1, column, row 2, column 1. Then, positive times 2, positive 2. Delete. So we'll have 3, 1, 4, 5. Negative 2, 16 minus 5, 11. 15 minus 4, 11. So the determinant is 0. Therefore, the given matrix has no inverse, does not exist. Okay? Kaya hindi ko ginawa tong example. Anyway, tong example na to, class, is only for finding the minors, cofactors, and adjugate. Okay? So, let's have another example. Find the inverse of a matrix A. So, this is for 2 by 2. By the way, class, how to find the minors and cofactors of 2 by 2? Pinakamadali sa lahat. Bawa, matrix B. We have 3, 5, negative 2, 0. Kunin natin ang minors. So we have B sub 1, 1, B sub 1, 2, B sub 2, 1. Apat lang, kasi apat lang naman yung elements eh. B sub 2, 2. 1, 1. So 3. Delete. 0. Okay? 1, 2. Delete. We have negative 2. Nakukuha? Again, B sub 1, 1. 3. Delete ang nasa right sa baba. Ang matitira, 0. That's the value of the minor of B sub 1, 1. 2, 1. This one. Delete. So we have 5. 2, 2. We have 3. Cofactors. Same process. B11, B12, B21, B22. I use B because the name of the matrix is B. The sum of this is even. Times 0, still 0. Negative times -2, +2. Positive times 5, 5. Negative. This is 2, 1, sorry class. Meron na palang, wait. 2, 1. Parehong 2, 2 nakuha ko. 2, 2. So, positive times 0, 0. Negative times -2, positive. Negative times +5, negative 5. Positive times 3, 3. Okay? So, that's how we get the minors and cofactors. Kung kailangan kunin ng adjugate, then you just continue. You get the transpose of your cofactors. Okay? So, let's go back sa inverse. Find the inverse of a matrix. Matrix A is 2, 4, 6, and 8. 2, 4, 6, 8. All right. 2, 4, 6, and 8. I might to pass. Are you still there?
Yes po.
Yes,
Yes.
ma'am.
Okay, so this is the given matrix. Let's find first we're going to check if the inverse exists. But before that, let's find first the determinant. Determinant of A. So 2 times 8, it's 16 minus 6 times 4, it's 24. 16 minus 24, it's -8. So since the value of the determinant of A is non-zero, therefore the inverse of A exists. Okay? To find the inverse class, it's 1 over the determinant of A multiplied by the adjugate of A. Okay? So bago natin makuha ang adjoint, we need to get the minors. A11, A12, A21, A22. A11, so 2. We have 8. 812, it's 4. Delete 6. 21, that's 6. Delete, we have 4. 22, that's 8. So we have 2. Cofactors, A11, A12, A21, A22. Positive times 8, 8. Negative times 6, -6. Negative times 4, -4. Positive times 2, 2. So the cofactors is 8, -6, -4, 2. Adjoint of A, transpose of your cofactors. 8, -6, -4, 2. Your row 1 become column 1. Your row 2 becomes column 2. And simplify. The inverse of A, 1 over the determinant is -8. So -1/8 multiply by your adjoint 8, -4, -6, 2. So we'll have Negative 1/8, negative 1/8 times 8, it's negative 1. Negative 1/8 times negative 4, it's positive 1/2. Negative, negative, so it becomes positive 6/8, or when we simplify, that's 3/4. 2 multiplied by negative 1/8, that is negative 1/4. So again, you can double check your answer. We know that A times A inverse, or A inverse times A, that is equal to the identity. Right? Ano nga ba yung identity matrix? 1, 0, 0, 1. Since this is 2 by 2. Right? So you multiply your matrix A by your inverse, your answer should be equal to an identity matrix. Okay, you can double check. 2 times negative 1, negative 2. Plus 12 divided 4, it's 3. So negative 2 plus 3, it's 1. So ito yung sinasabi ko, class. 2, 4, 6, 8. Multiply by your inverse, negative 1, 1/2, 3/4, negative 1/4. Should be equal to the identity. Negative 2 plus 3. It's 1. Ba? Row by column. Row 1 by second column, 2 times 1/2, that is 1. Minus 1. Kasi 4 times negative 1/4, that's 0. That is minus 1. So we will have 0. Again, 2 times 1/2, it's 1. Minus 1, 0. 6 times negative 1, negative 6. This is 24/4 or 6. So negative 6 plus 6, 0. 6 times 1/2, it's 3. 8 times negative 1/4, that is negative 2. So 3 minus 2, the answer is 1. So therefore, our inverse is correct. Kasi nakakuha tayo ng identity matrix. Question, class. All right. Any question? I'm going to save the attendance for today. So make sure nakapag-attendance kayo. Any question, class? So that's module 3, all about determinants. For your activity today, you're going to answer practice exercise A. Okay, so that is 1 to 10. Do you have any question?